Hey everyone, I'm Akshay Rose, and today I will be presenting my CE888 project title, Machine Learning Model for Minimizing ADHD Misdiagnostics in Female Patients. The project overview. This project supports the NHS efforts to build an explainable machine learning tool using fMRI and socio-demographic data. The goal is to help the GPs make early and accurate ADHD diagnostics, especially for female who are often underdiagnosed due to slower symptoms. This is my flowchart, which you can see. I merged and cleaned the data. I merged and cleaned the data from multiple sources. I balanced the imbalance class using SMOT, used recursive feature elimination and random forest for feature selection. I applied two classification decision tree. First was the decision tree, and the second one was XGB classification. XGB classification, and in the final, it was the conclusion part. In stage one, we imputed the missing value, avoid removing outliers to train the model realistically and visualize the distribution. In stage two, we found severe class imbalance, especially for female ADHD. Using SMART, we rebalanced the dataset to improve the model fairness and accuracy. So that's how I prepared a robust multi-class predictive pipeline in which there were 4 classes: 0, 0, 0, 1, 1, 0, and 1, 1. I first used the decision tree and the XGB classifier. We built the robust pipeline for both binary and multi-class problems. If I can say that in multi-class, XGBoost gave around 53% this accuracy. But struggle with the minority class, which was 1-1. ADHD, 1-1 represents ADHD in female candidates. Binary XGBoost for HDHD outcome yields around, okay, this is the HDB classification. Decision tree was also low, around 41%. So we cannot come to the conclusion that this label stratification is a good option for predicting the misdiagnostics in female patients. So we move on to the separate prediction classes. Separate prediction classes, I mean ADHD outcome and the female class separate one. So in this, the binary XGBoost and ADHD, this one decision tree reveals around 77 and similar. XGBoost really, accuracy of around 78%. And recall was also good, high precision, 81%. 81% precision was the recall for ADHD, and ADHD precision was 0.81, recall was 0.88, and accuracy of 0.78. And for the sex, if I would say that it has an accuracy of 0.59, and but the classification for female candidates, it was just 0.33. We can say that it was not able to predict, even with the decision tree, it was 0.48. We can say that we cannot predict due to imbalance in the data set. The machine failed to predict the sex in the female candidates. So XGB classifier with single target prediction like ADHD outcome proved better model for misdiagnostics in the participant, 79% accuracy we have seen in the previous slides. However, the gender prediction is not better, but this can be perfectly done with manual other ways like visiting or just calling the participant. Okay, and to remove the biasness in the data set requires large sample, but we don't have small sample. So we have small sample which may prevent which may pump error in the module. So I used a smart function. In this case, I use smart function for its for removing the biasness. If I would suggest, NHS must also record the sleeping hour duration, which could help greatly with ADHD diagnostics. And in case of data collection, it should also include substance abuse like drinking habits, smoking tobacco, etc. Thank you. And this is the link where you can get my recording for this project. Thank you. Thank you, everyone.